Solve the system of equations by converting to a matrix equations. X plus y minus 2z equals 3. 2x plus 5z equals 11. 2x plus 3y equals 12. The coefficient matrix is a 3 by 3 matrix. The first row is 1x, 1y, negative 2z. The second equation is 2x, 0y, 5z. And the last equation is 2x, 3y, and 0z. This is called the coefficient matrix because these numbers are the coefficients. They are in front of the variables. The variable matrix is the matrix with the entry x, y, z. These are the variables. Equals the constant matrix 3, 11, 12. We call the coefficient matrix A, the variable matrix X, and the constant matrix B. This is AX equals B, a matrix equation. To get X by itself, we would multiply the inverse of A on the left-hand side of A. And since we multiply A inverse on the left-hand side, we would need to multiply A inverse on the left-hand side of the right-hand side as well, because matrix multiplication is not commutative, so we can't switch the order. A inverse times A, the product is an identity matrix, so we have I times X equals A inverse B, but I times X is X, so X is A inverse B. This will give us the solution where X, so X, Y, and Z. A inverse B will give us a 3 by 1 matrix, and these will be the solution to the given system of equations. So how do we obtain these entries? We will take the inverse of the matrix A times the constant matrix B. But first, we would need to find the inverse of A. To find the inverse of A, we first rewrite the coefficient matrix 1, 1, negative 2, 2, 0, 5, 2, 3, 0, and we attach the identity matrix next to it of the same dimension. This is a 3 by 3 matrix, so we would need to use a 3 by 3 identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. And we would perform the series of row operation and turn the left half into an identity matrix. Simultaneously, we will turn the identity matrix on the second half to another matrix, and this matrix will be guaranteed to be A inverse. First, we would need to get rid of 2 in the second row, and to do that, we can take negative row 2 add to row 3 to get the new row 2. This is 1, 1, negative 2, 1, 0, 0. So we keep the first row. We also keep the third row 2, 3, 0, 0, 0, 1. The new row 2 is negative row 2 plus row 3. The negative of row 2 is now negative 2, 0, negative 5, 0, negative 1. And we take the new row 2, which is the negative of the previous row 2, add to row 3 to obtain the entries for the new row 2. And this is 0, 3, negative 5, 0, negative 1, 1, where we take negative row 2 plus row 3. Next, we will turn this entry 2 in the third row into 0, and to do that, we can take negative 2 times row 1, add to row 3. This row operation will give us the new row 3, so we'll keep row 1 and row 2. To obtain the new row 3, negative 2 times row 1 is negative 2, negative 2, positive 4, negative 2, 0, 0. And we add to row 3, which is 2, 3, 0, 0, 0, 1. This will give us 0, 1, 4, negative 2, 0, 1. And these are the entries for the third row. 0, 1, 4, negative 2, 0, 1. We see that in the third row, there is a leading 1 in the second column. So we would interchange row 2 to row 3 to obtain an equivalent matrix. This is 1, 1, negative 2, 1, 0, 0. And row 2 becomes row 3, 0, 3, negative 5, 0, negative 1, 1. And row 3 becomes row 2, 0, 1, 4, negative 2, 0, 1. Next, we would turn the non-zero 3 in the third row into 0 by taking negative 3 times row 2 add to row 3 to obtain the new row 3. So we will keep row 1 and row 2. Negative 3 times row 2 will be 0, negative 3, negative 12, positive 6, 0, and negative 3. We then add it to row 3. 0 plus 0 is 0, negative 3 plus 3 is 0, negative 12 plus negative 5 is negative 17, positive 6 plus 0 is 6, 0 plus negative 1 is negative 1, and negative 3 plus 1 is negative 2. To obtain the one entry in the third column, in the third row, we will take row 3 and multiply negative 1 over 17. This is the same as taking the third row and divided by negative 17. So the third row is 0, 0, positive 1, negative 6 over 17, positive 1 over 17, and positive 2 over 17. Again, taking the third row and divided by negative 17. We then keep the first row and the second row. This is now in row echelon form for the first half of this matrix. We still need to turn this into a reduced row echelon form by turning this 4 into a 0. And we can do that by taking row 3, multiply negative 4, and add to row 2 to get the new row 2. So we keep the first and the third row. Negative 4 times row 3 will be 0, 0, negative 4. Negative 4 times negative 6 is 24. Negative 4 times 1 is negative 4. And negative 4 times 2 is negative 8. We still have 17 in the denominator. Add this to row 2, which is 0, 1, 4, negative 2, 0, 1. 0 plus 0 is 0. 0 plus 1 is 1. Negative 4 plus 4 is 0. 24 over 17 minus 2, which is the same as minus 34 over 17. So this is negative 10 over 17. Negative 4 over 17 plus 0 is negative 4 over 17. Negative 8 over 17 plus 1 is the same as negative 8 over 17 plus 17 over 17. And this is positive 9 over 17. The second entry is therefore 0, 1, 0, negative 10 over 17, negative 4 over 17, 9 over 17. Next, we will need to turn the negative 2 and 1 into zeros. First, To turn the 1 into 0, we can take row 1 minus row 2, which is the same as taking row 1 plus the negative of row 2. We then keep the second and the third row. Taking row 1 minus row 2, 1 minus 0 is 1, 1 minus 1 is 0, negative 2 minus 0 is negative 2, 1 minus negative 10 over 17 is 1 plus 10 over 17, but 1 is the same as 17 over 17, so this is 27 over 17. 0 minus negative 4 over 17 is positive 4 over 17. 0 minus 9 over 17 is negative 9 over 17. This is not quite the identity matrix on the left half. To turn the negative 2 to 0, we can take 2 times row 3 added to row 1 to get the new row 1. And so we will keep row 2 and row 3 still. 2 times row 3 is 0, 0, 2. 2 times negative 6 is negative 12. 2 times 1 is 2. And 2 times 2 is 4. We then take this and add to row 1, which is 1, 0, negative 2, 27 over 17, 4 over 17, and negative 9 over 17. The entry for this new row 1 is therefore 1, 0, 0. Negative 12 plus 27 is 15. 15 over 17. 2 plus 4 is 6. 6 over 17. 4 plus negative 9 is negative 5 over 17. The left half is now the identity matrix I sub 3, and the right is therefore the inverse matrix A inverse. To obtain the solution, we take x equals A inverse times B, but A inverse is the matrix 1 over 17. This is the scalar. We can factor it to the front of the matrix. We obtained 15, 6, negative 5, negative 10, negative 4, 9, negative 6, 1, 2, and we multiply the coefficient matrix, which is the numbers on the right hand side of the given system of equations, 3, 11, 12. That is the matrix B. The matrix B is 3, 11, 12. Using the inner products, we have 1 over 17 times the matrix. The first entry comes from the inner product of the first row times the only column, which is 15 times 3 plus 6 times 11 plus negative 5 times 12. This is 45 plus 66 minus 60. 66 minus 60 is 6. 45 plus 6 is 51. The second entry comes from the second row. Multiply the only column. Negative 10 times 3 plus negative 4 times 11 plus 9 times 12. This is negative 30 minus 44 plus 108. Negative 30 minus 44 is negative 74. Negative 74 plus 108 is positive 34. The third entry comes from the inner product of the third row and the only column. This is negative 6 times 3 plus 1 times 11 plus 2 times 12. Negative 18 plus 11 plus 24. 11 plus 24 is 35. 35 minus 18 is positive 17. the scalar 1 over 17 times the matrix 51, 34, 17 is 51 over 17 is 3. 3 times 17 is 51. 34 over 17 is 2. 2 times 17 is 34. 17 over 17 is 1. And so we conclude that the solution to the system of equation is x equals 3, y equals 2, z equals 1. As we can see, this is a very inefficient way to solve the system of equation, but the idea is that we can use the inverse matrix to solve the system of equation. This is better suited for computer or a graphing calculator.